So I need to suppose h of x is that, compute h prime. Okay, so h of x is a quotient. So to compute h prime, I'll need to use the quotient rule. So h prime of x is going to be equal to, so you can do a low, so the bottom function, derivative of the top, minus high, which is the top function, derivative of the bottom, which is 1, over the bottom squared. Then it says to refer to the graph of f above to evaluate h prime of 1. So when I plug in 1 for x there, I get h prime of 1 is equal to 1 times f prime of 1 minus f of 1 times 1 over 1 squared. So I can find the values f prime of 1 and the value f of 1 by looking at the graph. So f prime of 1, I can see the slope of f at 1 is 0, and f of 1 I can see as negative 1. So I'll have 1 times 0 minus negative 1 times 1 over 1. So that gives me 0 plus 1 over 1. So the answer is 1. Number 2, define a of x by that, refer to the graph above. So a of negative 2 is going to be the integral from 0 to negative 2 of f of t dt. Okay, and so if I look at the function here, so from 0 to, it's kind of flipped around, so I'll do negative of the integral from negative 2 to 0, f of t dt. And if I look up here at the function f, if I go from negative 2 to 0, I get this triangle here. And the area of that triangle is 1/2 the base, which is 2, times the height, which is 1. So the area under the curve there is going to be 1. And so, but then I have to do the negative since I had to switch the bounds there. So the answer there is 1. Then a prime of 2. Well, let's spend a minute thinking about what a prime of x is. A prime of x is going to be the derivative with respect to x of the integral from 0 to x of f of t dt. Now this is directly from the fundamental theorem of calculus part 2. And the fundamental theorem of calculus part 2 says that this is equal to f of x. So a prime of x is equal to f of x. And so a prime of 2 is equal to f of 2. And so I can evaluate f of 2 by looking at my graph, and I see if I go over here to x equal 2 and go up, the y value is 1. So the answer there is 1 as well. And then a double prime of negative 1, that's going to be, if a prime is f, then a double prime is f prime. So this is equal to f prime of negative 1. And if I go over here to negative 1 and I look at the slope there, I can see that if I go up 0.5 and over 1, so the rise is 0.5 and the run is 1, which I could just write that as 0.5 is the answer there. These I'm just computing derivatives, so I want to find the derivative there. Okay, so when I look at this, I see some chain rule stuff going on. I'm going to rewrite my function as y equals cosine of 3x, the whole thing squared, because that's what the cosine squared means. And I think if you write it this way, it's a little easier to see the outside and inside functions. Okay, and so if I take the derivative dy dx, first I'm going to deal with the squared part. So it's going to be 2, all of that stuff to the first, and I'm going to leave the inside alone. Okay, so I've dealt with the squared part, now I'm going to deal with the cosine part, so go in one layer. The derivative of cosine is negative sine, so negative sine of, and I'm going to leave that 3x alone. Okay, and then I'm going to multiply that by the derivative of the inside function, which is just going to be the derivative of 3x, which is 3. And I'm done. And you can leave it just like that. You don't need to do anything. But make sure you put parentheses around this negative sign because you don't want it to look like it's a minus sign subtraction. You need to make sure you can tell that it's multiplication. Okay, so, on this one, I want to find the fourth derivative. Okay, so let's keep going here. F prime of t is going to be 4e to the, okay, so the negative is going to come down. So I'll have negative 4e to the t plus, and then 5, and then derivative of e to the t is e to the t. F double prime of t, again, another negative is going to come down from that. So I'll have positive 4e to the negative t plus 5e to the t. And then the third derivative, another negative is coming down. So I have 4e to the negative t plus 5e to the t. And then if I take the fourth derivative, another negative is going to come down, so that'll make it a positive 4e to the negative t plus 5e to the t. And so what I'm seeing there is that negative, I have a negative for each of the odd derivatives and a positive for the even derivatives. Okay, so the next one, I want to find g prime of x. So we'll notice that the structure of this function is that it's a product of two functions. So that means when I take the derivative, I'll need to use the product rule. So g prime of x is going to be the derivative of the first times the second plus the first function times the derivative of the second. Okay, so I want to do here the derivative of natural log x is going to be 1 over x. And then on this one, I'm just going to write the natural log x just like it is. For this other one, I'm going to do the secant x just like it is here. And then the derivative of secant, which is secant x tangent x. Okay. So we can call this guy like f and this guy like h. And so we'll have f prime, f, h prime. So that's how the product rule goes. The next one, I have e to the x to the e, ex. Okay, so the derivative of f with respect to x. The derivative of e to the x is e to the x. The derivative of x to the e, remember that x is just a power rule. So it's going to be ex to the e minus 1. That e is just a constant. We'll treat it like any other number. Plus, and then I'll have e times x. So the e is going to stay put. The derivative of x is 1. So we'll leave it like that.